Okay, so now we're going to go over a bent part with parallel bend lines. So parallel bend lines means that this edge tangent line is going to be parallel to one of our edges over here. It also happens to be parallel to our two edges over there. So the first thing to do is check the GMW sheet. So this can be found in the teams um, under, I have it mapped to my drive again, just go into your regular teams. But under the subteam leaders channel, MB26, manufacturing and ordering, laser cut, GMW K factors. So this brings you to this sheet over here, which gives you the material, the actual thickness with the nominal thickness in brackets, the bend radii that they have available, and the K factor associated with that bend radii. Ignore things that have two different K factors, that's because they're unsure, but we shouldn't need those. So for most parts, you're going to have steel. It's going to be probably gauge 11. So that has a real thickness that you need to put in as 0.1196. And the preferred bend radii for all steel parts, unless you absolutely need a larger one, which there really shouldn't be any reason, is 1 millimeter or 0.039. So say we're making a part that is gauge 11 steel, 1 inch nominal again, 0.1196-inch actual, a bend radius of 1 millimeter or 0.039 inches. Our K factor we can read here as 0.26. K factor is the same as neutral factor. In our case here, we have an aluminum part. So going back to my sheet, this is going to be aluminum. It is going to be 1/8 nominal, so my exact thickness here needs to be 0.1285, and this is called gauge 8 aluminum. There are different bend radii available. I'm using 6061 aluminum, which has a tendency to crack, so you want to make sure you're at least the material thickness, if not more if possible. So I'm going to go double the material thickness and choose bend radii of 1/4. So that's going to be a K factor or neutral factor of 0.596. So here I'm going to go into my part, go into the expressions menu. Unless I've manually changed it in some other way, I'm going to want this to be 0.1285. Again, 0.1285 is the actual thickness of the material, sheet metal material thickness. Ensure this matches your first tab. So mine does, sheet metal material thickness. Then I'm going to go into my neutral factor, which again is the same as your K factor. If I can find it, sheet material neutral factor 0.596. Again, that needs to match 0.596 for the 1/4 inch bend radius that I chose. Finally, the bend radius can also be an expression. So sheet metal material thickness, bend radius. Here I have it set to sheet metal material thickness. So that's actually wrong. I'm going to want it to be 1/4 inch, which is what I chose. And again, go to the first bend you described. If you go to bend parameters, bend radii, or bend radius should be 0.25 inches. And your neutral factor is going to want to match what you found in the spreadsheet. Sorry, in the text file. This text file. Okay, so once you have all that selected, you are good with your 3D model. The couple other points we have here are to make sure dam edges are as large as possible. So for example, if there's a way you can enlarge this, here it's okay because you have two, but say you only had one and it's hard to get this flat because it's such a short flat surface, you'd want to make this a bit longer if possible. So say decrease these radii since they're probably not that necessary. So we're going to firstly want to control to get sheet metal. We want to make sure we have our flat pattern. I already pressed this button, as you can see over here. So we're going to export our flat pattern, DXF. Name it. So before we name it, we need to go into our ordering sheet. We're going to call our part drivetrain rear guarding. It's going to have the ID of DRS2 00 5. We're going to make one of them, and we're going to check this bending needed part. Once we have all of 3 files created, we're going to enter this as yes, and that's all we need. So remember DRS 2005. Coming back here then, we're going to name this, put it somewhere you remember to then upload it to Teams. Name this DRS 2005. Here we go. Sorry, not DRS. This is aluminum. So DRA. I'm going to go ahead and change that over here as well. So this needs to go under the gauged aluminum. And this is going to be DRA and bent over here. So make sure you put it in the correct tab over here. Cool. So having done that, we are good to go. We've exported our DXF, and we can go ahead. So when we export a DXF, very important to check this menu. You do not want this clicked. You do not want anything, these two clicked. Only clicked ones are this one, and that one. Whoops. So I was going to say, put it in somewhere you know. So I'm going to put it in my personal drive, and we're going to call this DRA 2005. I already exported it, whatever. Make sure it's a DFX file. Perfect. So now we've created our DXF. We're going to jump into AutoCAD. Open our DXF up. So DRS DXF. I don't know what this BK is. You can ignore that. I must have exported too many times. Cool. So procedure is the same for here. Change this all to by layer. Move the coordinate system to approximately the bottom right of your part. Importantly, bend lines, if they are parallel, do not need to be included. And then do what you always do with your text. Properties, yellow. And then we are good to save that. Make sure you save it as a DXF. You can override the last one, and that's good. So jumping back to NX, finally, we're going to want to export a step file. So any bend part also needs a step file. Again, we're going to name this DRS 2005. Make sure you know where you're saving it. I happen to know. Yes, we can save over that. Perfect. Now we have our step file. And the last thing is our drawing. So our drawing, you're going to import the template. You're going to put your part name, DRA. I named the step file wrong, but that's okay. Don't do that. Material is going to be aluminum. And this is going to be 6061. So make sure you put the grade T6. We're going to want one of these. It's going to be drawn by me, and you can put in the date. There we go. So base view, the first view we're going to want is our isometric view, flat pattern view. So you can go ahead and place that. And you're going to want your isometric view, which you're going to put in your top right. You're probably going to want to make this scale smaller since it's just for reference. They're not taking measurements off of it. Go ahead and hide these lines. They don't look very nice. Importantly, this view, as you can see, there are way too many bend lines here. So you're going to go into settings, and you're going to see this menu. You're going to expand out flat pattern view. And the only ones you want to show are this one and that one, and interior cutouts and exterior. Everything else you can go ahead and hide. Mainly those three. Anyways, all of those don't really matter. So you're going to press apply. You can see all of those left. So you're going to make sure these two are the ones that are checked. First thing is to make your bounding body. So bounding body, there we go. Gonna change this to shows your length zeros. Perfect. So bounding body dimensions. That's our bounding body dimensions. Then we're gonna want to dimension only our bend line. So we're going to give them a reference of the edge of our part on this side, and we're also going to give them a reference on the other side so that they can pick which side they datum off of. If you have got two edges like that that look lined up, first make sure they actually are exactly lined up. And to show that, you're going to extend your line through both edges, like so. So that's it for our flat pattern view. The next view we're going to take is a view normal to our bend. So as you can see, the view normal to our bend is going to be this view. So select that edge and you can press OK. And we're going to place this view over here. We don't have a lot of room. If you ever run out of room, feel free to make a second sheet and just convert them into a single, merge the two sheets into a single PDF. That is a-okay. In my case, I'm just going to make it work. Oh, one more thing. So, sorry. So first, we're going to dimension the inside edge of our bend, like so. We're going to dimension the angle of our bend, like so. In this case, it's 90 degrees, nice and easy. And we're going to mention flanges of our bend. So in this case, it's 90 degrees, easily to measure outside to outside. That's one dimension. And then outside to outside. That's our second dimension. Cool. Make sure this doesn't interfere too much. You can pull it there, make it look a bit nicer. There we go. So then we're going to add our notes. So we've got our note on our, so I have it selected. So I'm going to add our k-factor note here. K-factor. So if we go back to our sheet, so this is going to want to match what we put here. So 0.596. Go 0.596. So this is going to be 0.596. That's not an inch. It's a this number. This is not gauge 8. This is gauge 8 for aluminum. If I go back to my sheet, gauge 8, 0.1285. So 0.1285. There we go. And we're going to place that in the bottom right. Ignore all these other ones I accidentally added. There we go. Lastly, we're going to want to, so make this not bold anymore. We're going to want to put a note on this bend. So this bend is going to be a bend up or a bend down. In this case, it doesn't matter. In all capitals, we're going to write in French, O for up, ba for down. Ba is spelled like this. So this can be O. We're going to write the degree of our bend, so 90. I'm going to add in the degree symbol in a sec. I need to copy paste it because I don't have it on my keyboard. And then the bend radius, which is 0.25. So you're going to put that here. If you have a horizontal line, you can also use an arrow by adding here a terminating object and an arrow like that. And then if you have an arrow, obviously put it outside your part. In my case, there's not too much going on. We can remove the arrow and put it just like so. Gonna pull in the degree symbol from the internet. There we go. I've copied it and I will now paste it. I just have a second screen here. There we go. So that should be it for the drawing. Sweet. And then I already pre-filled out. Oh no, we did this together. Amazing. Now we're gonna export this to a PDF. Again, I'm going to name this DRA 2005. It's going to be a PDF. Perfect. There we go. So now we're going to make sure we put all those files in the right spot. So ignore all these other files that were created. Those can go away. It's not happy about that. Okay, I don't know what that file is. You can just ignore it. 2000 dra. So where is my step file gone? GXF, PDF. Okay, we can just go ahead and re-export our step file. I am not sure what happened to it. So export our step file again. That's you need to be in the modeling application, export step. Oh, I put it in the wrong drive. That is why. So I'm gonna put it here so I know where it is, and this we're gonna call DRA 2005. There we go. So coming back here, it should be here. Where is my step file? Oh, DRA 2005. No, it should be there. Unless I've just not seen it. There we go. So our files are the PDF file, the DXF file, and the step file. We're going to copy those and put them in the Teams. Again, I have the Teams mapped to my computer, but you can do this through how you usually access Teams. So MV26, we are in the, not the drivetrain teams. In the subteam leads teams, MV26, manufacturing and ordering, laser cut. Let's say this is laser cut 2. Our piece is aluminum 6061. And it is gauge 8, 0.125 nominal. We're going to paste in our files here, named with the right names. And you are done.